Today we're going to solve this problem. Search a 2D matrix. So the problem statement says that you are given an m times n integer matrix with the following two properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if target is in matrix or false otherwise. You must write a solution in big O of log m times n time complexity. So let's take a look at the example. Suppose this is the matrix and we have to look for the target. If that target exists in the matrix, then we're going to return true, else we're going to return false. So in this example, 3 exists in the matrix, so we return true. And in this example, the target is 13, but it does not exist in the matrix, so we return false. Now, let's think like how we're going to solve this problem. So first things first, since our matrix is like sorted, so I think binary search is the perfect candidate to solve this problem. So basically in a standard binary search, we initiate the left pointer at index 0 and right pointer at the last of the array. Okay, and we find the mid, we calculate the mid, and if that target exists in the if that target is greater than the mid, then we search on the left, and if it's greater, then we search on the right. Cool. This is the typical binary search approach. Now let's dive into the code. So first things first, gonna initialize row and column. M is the row and n is the column. So let m is equals to, this should be matrix dot length. This should be the row. So first we take care of the corner case. Like if this m dot length, if it's equals to 0, then we simply gonna return false. Cool. Let n, which is column, this would be matrix index 0 dot length. Okay. Now let's do the binary search. So for the binary search, we initiate at left pointer to 0 and right would be m times n minus 1. So we initiate left pointer to 0 and the right would be at the last of the array, that would be m times n minus 1. Now we typical binary search approach, while we'll run a while loop. I will check if this left is less than or equals to right. Now we'll find the mid. So let's call it pivot index. So this should be left plus right divided by 2. Actually, in order to avoid overflow, we can also do right minus left. There's actually one more way to find the mid. It would be right plus left minus right divided by 2. But this is the much easier easier to like find a simpler way to find the pivot index. Cool. Now we found the pivot index. Now we'll find the pivot element. Let's say pivot element would be, basically this would be matrix row and column. Row would be pivot index divided by n, whereas column would be pivot index modulo n. Cool. Math.flow. Okie dokie. It would be math.flow. This would be pivot index divided by n, and the column would be pivot index modulo n. Since n is the column. Now we found our pivot element. Now conditional check. If this pivot element, if it's equals to target, so yeah, we'll return true. We got the answer. Else we'll check for the two conditions. If that target is less than the pivot element, that means, what that means? That means we have to search on the left, else we have to search on the right. So let's say if this target, if it's less than pivot element, means that this pivot element is greater than the target, then of course we're going to search on the left, right, since our target exists on the left of the pivot. So this would be pivot index -1, since we are searching on the left side. Else, if that target is greater than the pivot element, then we're going to search on the right. So this would be left is equals to pivot index +1. Lastly, we'll get out of this for loop and going to return false, since none of the conditions met. So we'll return false. Cool. The time complexity of this approach would be big O of log mn, where m is like length of the matrix and n would, where m is the row of the matrix and n would be the column of the matrix. And since we are performing a standard binary search, so it takes big O of log mn, and space complexity would be big O of 1, since we are using constant access space, right? So let's run this code and let's see if it works. I hope it does work. Okay, we have a typo here. This would be left actually. I don't know why like this LeetCode is getting slower. Like previously it used to be fast, but I don't know like why this thing is happening. But let's run a code and I think it should work. So yeah, that's it. Thank you for watching. Later.